Okay, so as we mentioned before, tree diagrams are a great way to represent any experiments where you have a couple of stages or you repeat a process or something like that. Generally, 2 or 3 is probably the maximum that you want to do. So let's have a look at this one. Probability the student owns an iPhone is 0.75. 2 students are selected at random, construct a tree diagram. So you either own an iPhone, so I'll put a P for owning an iPhone and a P dash for not owning an iPhone. So that's student 1, and the probability of 0.75 of owning it. In fact, I'm going to change that. What I prefer to get in the habit, especially if we're tech free, let's put our probabilities as fractions. So 3/4 of owning of iPhone, 1/4 of not. The second student, okay, has an iPhone or they don't. And again, 3/4 or a quarter. Second student owns an iPhone or they don't. 3/4, a quarter. All right. So if you follow the branch, obviously, that top branch, both students, is the answer to question A, isn't it? So if both students own an iPhone, we're looking for that branch there, a PP. So we can just even just write that. The probability of iPhone multiply across the branch. And this is why I prefer fractions, because I think it's much easier to tell that 3/4 by 3/4 is 9 on 16, as opposed to 0.75 by 0.75. Okay. Part B, the probability that only one student owns an iPhone. So only one of them. So if we have a look at one student owning an iPhone, I could go, has an iPhone, doesn't have an iPhone, or doesn't have an iPhone, has an iPhone. So they're the two pathways, aren't they? So if I multiply along those pathways, I've got 3/4 by 1/4, which is 3/16, and then I've got 1/4 by 3/4, which is equal to 3/16. So if I add them together, I get 6/16. So there's my answer to B. I won't worry about writing it out. All right. So let's have a look at example 16. Suppose at a certain town, the probability that it is sunny on Saturday is 3/8, and if it's sunny on Saturday, then the probability that it's also sunny on Sunday is 5/8. Okay, so we've got consecutive sunny days. So let's call S for sunny, not sunny. So we'll just put an SU. That's not much better. I can't even do Sunday. We'll just have to do sunny. Sunny, not sunny. And the first column is the Saturday result. Okay, so what is the probability? Sunny on Saturday is 3/8. So that's 3/8, which means 1 minus that, which is 5/8, is the probability of it not being sunny. Okay, then we go to the next day where it's sunny or not sunny, sunny or not sunny. Now, instead of being 3/8 and 5/8 again, it changes slightly. That's my Sunday result. Now, it says that if it is sunny on Saturday, then the probability that it is also sunny on Sunday is 5/8. So this path here is sunny on Saturday. So this one here is sunny on Sunday. So that must be 3/8. However, if it's not sunny on Saturday, which is this pathway, the chances of it then being sunny the next day is only a quarter. So that's the chance of being sunny is 3/4. So 3/4 is the chance of it not being sunny. Okay. So whilst normally in our tree diagrams or regularly the probabilities don't change, it's not that uncommon for the probabilities to change on each branch or after each experiment. So there's my tree diagram. So let's have a look at part I. What is the probability that it is sunny on both days? So sunny both days is sunny to sunny. So that's simply going to be equal to So the probability of a sunny is equal to 3/8 by 5/8, which is 15 on 64, part 2. Probability that it is sunny on Sunday. So for it to be sunny on Sunday, let's think about that. Sunny on Sunday means it could be sunny on both days, sunny, or it could be not sunny and then sunny. So there's two possibilities there, isn't it? So that's equal to a probability of a sunny, which we've worked out, plus the probability of a not sunny. So sunny, we worked out to be 15 on 64, plus not sunny is 5/8 times sunny, which is only 1/4. So I've got 15 on 64 plus 5 on 32. So let's make that on 64, which is 15 on 64 plus 10 on 64. So 25 on 64 is the probability of it being sunny on Sunday. All right. Just go back a step. Conditional probability is highlighted in this example in some ways because these results here in my, say that sunny result there, that 5/8, which we had here, was dependent upon whether it was sunny the day before or not. So if you look at the two sunny probabilities, one of them is 1/4, the other one is 5/8, and the value that we use depends upon what happens the day before. Let's have, what have we got? Okay, so that leads us into what we call a little bit of conditional probability. So that's what conditional probability is. The probability of what happens may be dependent upon what happens previously. So the terminology, okay, is when what happens one event depends on the previous event. Now that A backslash is sometimes written probability of A. In the book, sometimes we use a vertical line, and it's read as saying that's the probability of A given B. So that's what's the chance of event A occurring given that B has occurred. All right, so in other words, what's the probability of it being sunny on Sunday given it was sunny on the Saturday? All right, so there's no doubt about what happened previously. And the rule for that, A given B, is just the intersection of the two events over the probability of B, the second one. Similarly, the probability of B happening given A happened, okay, so B given A, the only difference is we can write it as B intersection A, which is the same as A intersection B, over the probability of A, the probability of the second one, all right? So let's have a look. Given the two events, A and B, A is that, B is that, and B given A is that, find the intersection. So what do we know about B given A? From my rules, the probability of B given A is equal to the probability of B intersection A over the probability of A. So the probability of B intersection A is equal to the probability of A times the probability of B given A. And I've got that information, which is 0.7 times B given A, which is 0.4, which is equal to 0.28. Okay. The next one says, what's the probability of A given B? So I'm just using my formula. A given B is equal to the probability of A intersection B over the probability of B. Now, A intersection B and B intersection A are the same thing. A intersection B we just worked out, which is 0.28 over the probability of B, which is 0.30 if you like. Now, we never ever leave our answers as a decimal on a decimal. If you want to think about it, you can multiply top and bottom by 100, and that makes it the same as 28 over 30. 2 goes into both of those, so that's 14 on 15. Okay? So never ever leave your answer as a decimal on decimal. All right, what about that multiple choice? If for two events A and B, the probability of A is probability of B is probability A intersection B is, then A given B equals, it's another formula, isn't it? So probability of A given B is equal to probability of A intersection B over the probability of B. A intersection B is 3/10 over 1/3. Flip it upside down and multiply, which is 9/10, which is D. All right. Example 19. We've got two 19s. That's okay. In a particular school, 55% of students are male, 45% are female. Of the male students, 13% say maths is their favourite. Why wouldn't they? Of the female students, 18% prefer mathematics. Draw a tree diagram. All right, so let's think about the tree diagram. So really, we've got two things to list. We either list the sex first, male or female, or we list their preference of maths. So in thinking about it, their preference of maths depends on whether they're male or female. So let's put male or female first. So I will put male. Let's face it, we could put M dash if we wanted to, but I'm just going to leave it as female. And then we either like maths. So let's change it slightly because I'm going to have like maths and not like maths. There's my M. So I'm going to actually lift the first column, which is the sex. You're either female or not female. And then the second one, when we talk about maths, you're either like maths or you don't like maths. Like math, don't like math. Let's have a look. So 55% of the students are male. So the probability of being not female is 0.55. Probability of being not female is 0.45. Now, sorry, of not male, 45% are female. Now, of the male students, 13% say maths is their favourite. So the male students, which is down here, 13% say maths is their favourite, which means that 87% say something else is. Of the female students, 18% prefer mathematics. So there's my 18 that prefer math, which means 82% don't prefer math. Yeah. So you can see the conditional part of it there, hopefully. That this 18% here, that was dependent upon, that was conditional upon the person being female. All right. So a student chosen at random prefers mathematics and is female. So the probability of mathematics and female, or female and mathematics, is just this pathway along here, isn't it? Is equal to 0.45 times 0.18, which I wouldn't expect you to do without a calculator. So the answer to that, 0.081. What about part B? A student chosen at random prefers mathematics and is male. Mathematics and male, which is not female, is mathematics. What's that? It's equal to 0.55 times 0.13. And on our calculator, equals 0.071. 715, I'll put 072. Okay, so it's just setting up that diagram there. This one. All right, in a certain town, the probability that it rains on Monday is 0.21. If it rains on Monday, then it probably rains on Tuesday is 0.03. If it doesn't rain on Monday, probably find the probability it rains on. Okay, tree diagram. It either rains or it doesn't rain. And this is Monday. Rains on Monday is 0.21, which means it's 0.79 that it doesn't. My second day, which is Tuesday, it either rains or it doesn't rain. I'll call that Tuesday. It either rains or it doesn't rain. Now, if it rains on Monday, then the probability it rains on Tuesday is 0.83. So it's raining on Monday and then raining on Tuesday, 0.83. So it's a rain. So the chance of it not raining is 0.17 because the probability is add to 1. If it does not rain on Monday, then the probability it will rain on Tuesday is 0.3. So not raining on Monday is down here on the second one. So then the chance of it raining is 0.3, which means the probability of it not raining is 0.7. What's the probability of rain? So the probability of rain is simply going to be 0.21 by 0.83, which on our calculator is 0.21 by 0.83, which is 0.1743. And then rain on Tuesday is the probability of rain plus the probability of no rain. Rain we've got 0.1743 plus no rain, which is 0.79 times rain, which is 0.3. So that's going to be equal to 1743 plus 0.237, 0.4113. Okay, give it a go.